Good day, everyone. Our topic for today is all about radius and interval of convergence of a power series. Now, let's first talk about the power series. In this section, you will see that several important types of functions, including fx equals ex, can be represented exactly by an infinite series called a power series. Now, in the definition of power series, if x here is a variable, then an infinite series of the form, this is a series, summation of an x raised to n as n equals to 0 goes infinity equals a0 plus a1x plus a2x squared plus a3x cubed plus until anx raised to n and infinity. This whole series or this whole form are called a power series. However, in the infinite series of the form summation of an quantity x minus c raised to n as n equals to 0 goes infinity equals a0 plus a1 times x minus c plus a2 times x minus c squared plus goes to an times x minus c raised to n goes infinity. And this whole form is called a power series centered at c, where c here is a constant. Alright? Now to find where the power series centered at, let's see the example. Now if we have series an times the quantity of x minus 3 raised to n as n equals to 0 goes infinity, so we will find where the power series centered at. So from this expression, the power series centered at, so we represent this form as x minus 3 equals to, so transpose equals to 0. So if you are going to transpose this negative 3 to right, it will become x equals to 3. So therefore, the power series of this certain expression is centered at 3. Next, the series of x raised to n over all over n factorial as n equals to 0 goes infinity. So the x here is raised to n, x raised to n. So if we have x minus 0 raised to n, so it will 0, right? Therefore, the power series of this certain is centered at 0. For the third example, we have 3x minus 2 equal to 0. So transpose the negative 2 to the right, so 3x equals negative 2. Divide both sides by 3, cancel 3, so x equals to, it's positive here, positive, so therefore x equals to 2/3. Therefore, from this given series centered at 2/3. So the power series centered at 2/3. Note that if the expression looks like this, automatically the series centered at 0. Now if the expression, as the definition of a power series, now if the expression looks like this, therefore the power series centered at c, where c here is a constant. So don't forget that c is a constant. Now let's talk about the radius and interval of convergence. So we have here 3 cases of the convergence of a power series. Now for a power series centered at c, so as our example, if a power series centered at c, one of the following is true. So don't forget that c here is a constant, any constant number. Now, one of the following is true if the power series centered at c. First cases, we have the series converges only at c. So if the power series centered only at c, then the radius is equal to 0. However, if the series converges absolutely for all x, all x, therefore the radius of convergence is infinity. But this case, our second case here, that there exists a real number r, or the radius here, r represent as the radius of convergence, r greater than 0, the absolute value of x minus c less than r converges. If the absolute value of x minus c less than r, then the series absolutely converges. But if the absolute value of x minus c greater than r, or it's greater than to the radius of convergence, then the series diverges. Let's demonstrate these three cases. Alright, so to demonstrate from three cases that we have, limit n goes infinity as the absolute value of un plus 1 over un is equal to 0 for all x. Therefore, the radius is infinity and the interval is negative infinity and positive infinity. Alright? However, if the limit as n goes infinity through the absolute value of un plus 1 all over un equals infinity, therefore x equals c as constant converges and the radius equals to 0 and the interval is the constant. And in the third case, limit as n goes infinity to the absolute value of un plus 1 all over un equals 1 over r absolute value of x minus c less than 1. Less than 1, so it will goes like divide both side by r is the radius, so you will divide both side through the radius, so the result will absolute value of x minus c less than 2r, or the radius of convergence. Now, if you will get this expression, you will proceed to this. As the absolute value of x minus c less than r is converges. So in this expression, if the sign here is less than the radius of convergence, then it converge. And if greater the value of x minus c greater than the radius of convergence, then it diverges. Alright, so from here, if it converge, then you both side negative r less than x minus c less than r, so add plus c plus c plus c here, and the result will negative r plus c less than x less than r plus c. So you will get this interval negative r plus c and r plus c as the interval if the whole expression converges and diverges. Alright, let's go with the example. Find the radius of convergence of the series n factorial x raised to n as n equal to 0 goes infinity. Now the solution for this series is we will use the ratio test. Alright, so to get the radius of convergence, we will use the ratio test. So as the ratio test, we have limit n goes infinity as the absolute value of un plus 1 over un. So we let un here, un equals to n factorial and x raised to n. And un plus 1 here equals to n plus 1 factorial as x raised to n plus 1. So this is our value of un from the given series. It will become limit n goes to infinity. Absolute value, so do not forget the absolute value. Un plus 1, so un plus 1 is here. So un plus 1 factorial times x raised to n plus 1 all over n factorial x raised to n equals, so limit n goes infinity, factorial, so to get the limit, so we will factor the expression. So n plus 1 times the quantity of n factorial, so to cancel the n factorial from below, so I use this form, times x raised to 1 all over n factorial times x raised to n. So cancel the same expression. So we have n factorial, so cancel, and cancel x raised to n and from below. So the expression will now limit n goes infinity as the absolute value of n plus 1, right? So n plus 1, we only have left n plus 1 and the absolute value of x. So limit n goes infinity, n plus 1 is infinity times the absolute value of x. So infinity times the absolute value of x is infinity. So if the limit here, from our cases, if you will get the limit infinity, therefore the radius of convergence is equal to 0. Yes, and x equal to c, therefore it converge, and the interval is equal to c. Now if we have the series of x raised to 2n over 2n factorial as n equals to 0 goes infinity, then we will find the radius of convergence with this form. So we let un equals to x raised to 2n all over 2n factorial, and un plus 1 equals to x to n plus 1 all over 2 n plus 1 factorial. To get the solution, we will use the ratio test. So limit n goes infinity as the absolute value of un plus 1 over un. So we have limit as n goes infinity, absolute value of un. So we have un here. So x raised to 2 times n plus 1 over 2 times n plus 1 factorial divided by un. So x raised to 2n over 2n factorial, then absolute value, equals limit as n goes infinity, absolute value, so we have x 2n plus 2, and distribute the value, then over distribute, so 2n plus 2 factorial, then times, you have to reciprocal, we will get 2n factorial over x 2n equals, we have limit as n goes infinity, we have x. So what will happen to cancel this expression? So I'm going to factor this out. So x raised to 2n times x raised to 2, then over this one, 2n plus 2 times 2n plus 1 times 2 factorial, then copy, so 2n factorial over sa x 2n. So we can now cancel the same terms. So we have x raised to 2n and x raised to 2n, then 2n factorial and 2n factorial. We only have left here limit as n goes infinity. So I will separate this n terms. So 1 over 2n plus 2 and 2n plus 1 and the x squared equals, so the limit here 0, it will 0 times x squared equals to 0. So from the cases that we've mentioned, that if the limit we get is 0 for all x, 0 for all x, therefore our radius of convergence is equal to infinity. And the interval here is equal to negative infinity and infinity. Alright. Each endpoint must be tested separately for convergence or divergence. As a result, the interval of convergence of a power series can take any one of the 6 endpoint of convergence. 6. Alright, so if the radius is equal to 0, then the endpoint of convergence looks like this illustration. We have the x-axis here and this dot here is the c. However, if the radius is equal to infinity, then the expression looks like this. X-axis, we have the x-axis here and it's infinities, alright? As you can see, it's infinity. And we will put c here at the center. Now, if the radius is r, then it has many cases. So, as the x-axis here, so if the value of c minus r and c plus r, so the radius of convergence is in here, between the c here and here. As you can see, the parenthesis, alright, diverges at this point and this point. And then, if the radius is converges at c minus r and c plus r converges, so therefore it looks like this expression. It diverges at this point and it converges at this point. So the radius here is at this. And the expression is converges at c minus r and diverges at c plus r. So therefore, the expression or the endpoint convergence is diverges at this point and converges at this point. And if the expression are both converges to the both, so converges to c minus r and converges to c plus r, so the expression looks like this. So the endpoint is here and converges at this point. So these are the endpoint of convergence. Let's see the example for this endpoint of convergence. Now, let's find the radius and interval of convergence of the given power series. If we have the series 1 over n times 5 raised to n times the quantity of x minus 4 raised to n plus 1, so to find the radius and interval of convergence of this power series, we will use the ratio test again. Alright, so ratio test, so we have limit as n goes infinity un plus 1 all over un equals limit as n goes infinity. So the un plus 1 here is we have x minus 4 raised to n plus 1 over n plus 1 times 5 n plus 1. Then divided by x minus 4 times n plus 1 over n times 5 raised to n equals, we have limit as n goes infinity, so we have x minus 4 n plus 2 raised to n plus 2 all over n plus 1 times 5 raised to n plus 1 times so n, it will become n times 5 raised to n over x minus 4 raised to n plus 1 equals limit as n goes infinity. To cancel the same expression, I will use x minus 4. It will become raised to n plus 1. Alright. And then x minus 4 raised to 1. So if you combine these two, the result is x minus 4 raised to n plus 1 all over. So n plus 1 times the 5 raised to n times 5 raised to 1. Then times, we can now cancel the same form. Cancel this and 5n n. So we only have left here is limit n goes infinity. I will separate this n term, so n all over n plus 1 absolute value of x minus 4 over 5. So equals, so this expression equals to x minus 4. We only have left x minus 4 all over 5. We get this limit. Therefore, we will use the second case. Alright, the second case of the power series. We'll get the second cases of convergence of a power series. It will become x minus 4 less than 2, 5. Therefore, we have, diba? From the second case, we have x minus c, absolute value of x minus c is less than 2r. So these are r. Therefore, our value of radius here is equal to 5. And our centered, the power series, this series is centered at 4. And therefore, the interval, to find the interval of convergence, so from this expression, x minus 4 less than to 5. So transposed 5, so transposed to the left, so it will become negative 5 less than to x minus 4 less than 5. So plus 4 here and plus 4 to the left. So the expression will turns like this. Negative 5 plus 4, it's negative 1 less than, so negative 4 plus 4 is 0, so x, so we only have left x, and less than 2, 5 plus 4, it's 9. So therefore, this expression, negative 1 less than x less than 9 is our interval. Therefore, the interval here is negative 1 and 9. And to demonstrate the end of convergence, the end point of convergence, so we have here, so that's line here, okay? Alright, that's line, x-axis, and we have here the c. So the c here is 4. Converges, so converges at negative 1 to 9. Therefore, this is our radius here and radius here. Alright, so I think that is all about how to find radius and interval of convergence of a power series. I hope that you learned something from this video. Thank you and goodbye.